Okay, see, visible, no? I think this data and whatever the text is there, they are all very small letters. Just for here understanding purpose, I taken all this mx plus b. B is a constant, so simple linear regression, so on. So okay. Now see here, I'll go with example 1 and example 2. There are 2 examples I have. Multilinear data sets. This is what I have. Okay. See here, what I'm doing is here I'm using a matplotlib inline. That is, yesterday we had seen this graphs, correct?
Yeah.
And another one is numpy. Okay.
Yeah.
Yeah, numpy is for arrays and also mathematics functions I wanted to use. Then we'll go for the numpy. Look at here. Now, see here, I have to estimate the coefficient, right? Okay. To estimating the coefficient, what I did, I have used one function called it as a coefficient estimated, right? Here I'll take the number that is size of x. What is the value of my x? And then I'm calculating, see, directly np dot mean of my x, np dot mean of my y. That is, I had to calculate. Just now I had shown you this formula, right?
Yeah.
Here the function is follows like this. Just I'll find size, the following circle number, the line will be given the number of observation of my n. Then I'll calculating the mean here also. Then after calculating the mean, sum of what y and x, this is formula that we have, right? That we find the cross deviation and deviation about the x. SS x, it is xy, xs with the my independent variable. Now this is the coefficient b1, this is the coefficient b0. We are calculating manually. Just I am showing the formulas, guys, here. Okay. Every time whenever you are performing this linear regression operation, no need to do all these things. Here in the next another example, I'll show you directly how to do all these things. Okay. Yeah, let me run this one. Okay, this is the defining a function which will calculate my important values of my SLR, that is my x and y. It is, see, I'll run this what to say, summation. Now the function which will plot the regression line, I need a best fit line now. Fine, between my x and y value. So what if I'll draw see, for that I'm wrote a one function called it as a plot regression line with respect to my x and y b. That is my value. See which plot I'm using, scatter plot. For x and y, color and all, I have mentioned all the parameters. See my y prediction value, this is the my mx plus c, this is what b0 plus b1 dot x. Plot with x and y is prediction, color is something green, labeled as a x, and oh, this is the function. It performs my line. Okay, just wait, it will show the line. See here. Okay, now I'll define a one function, called it as a main. What is this main? Say here I'm taking a values, that is an array of value, and x is something array of value, b is y is values, and I'll calling this function coefficient estimator. Where is my coefficient estimator? Here, this is the estimator I'll go to call. Okay, see here. Okay, 1 minute. I'll clear my what to say, so that you'll understand. Guys, look at here. This is what calculation of my coefficients. Once this is over, let me do the prediction. That is y is equal to mx plus c. Okay, I'll call my function. Why this line is not coming? When I call this method main, see here, this is what I have estimated. When I call this method main method will call what? This coefficient b, and then it will call this method plot regression line. See here, with respect to this one, what is my beta naught? Beta naught value is 151, and b1 value is what? This is one way. This is what my regression line. Some few of the points are on the line, few of the points are below the line, some few of the points are above the line. Getting it, guys?
Yeah.
Okay. See here, I have a function. Are you typing or what? Guys, please. Is it my, I am audible?
Yeah. Yep.
Yeah. So this is what mathematical way you are performing. No? This is the simple, very simple linear regression. How I'm plotting, this is what I'm showing. Guys, I'll clear everything. Look at here. Okay, what is this one? Here I'm importing the my library, then I'm calculating my coefficients for x and y. The formula that what you have statistic function, that is mean x and mean of y, and I doing the summation minus this values ss x, and for with respect to I'm calculating my coefficient b1 and b naught. This the function performs calculation all these things. Let me run this coefficient function. Okay, later I have to draw my regression line. I have wrote one function, that is a plot regression. This is a one more function. See here, I defined a one more function. There are three functions in the main. In the main function, I'm calling, I'm providing x value, and I'm providing the b value, sorry, x and y value. I need b. B is calculated by using this function called it as a coefficient x comma y. Correct? Okay, guys, please.
Yeah.
Okay, now what happens? I am printing that value. Then I'll call this function plot regression line. That is the function that I have in the line number 40. Okay, this is what my main function. Fine. Now whenever I require, just I'll call a main function. When I call this main function, it will call what? Coefficient estimation and plot regression, both the functions. So okay, when I call this function, what happens? See, this is my simple linear regression. Okay, x and y. What is x? X values are taken 0 to something called it. See here, I have mentioned the value of x 0 to 9. Y value is 100 to 1250 values it has been taken. So with respect to this x, y value is been calculated. That is the relationship among. There is a positive relationship among x and y. When x changes, obviously y is also changing linearly. Am I right? Guys?
Yeah.
Now, this is a very this is a very simple basic calculation. After the estimation, see coefficient of B1, B2, that is B naught value and B1 value has been calculated. We have printed. Now, let me come to this another example. Look at here. Here, it's something good. my MATLAB, I use the NumPy. Here I am using the one more data set, that is a sklearn data set. That is a sklearn library. From this, see here, this library is having my, what to say, linear model, and then it consisting of a data set. See here, I'll not, whatever the things, whatever I have done, I'll not going to do it. This one here, this linear model will perform all those things. Another method, see here, from sklearn dot matrix, import what? See here, mean square error. See, ready-made functions are there, and R square, correct? R square, adjusted R square, we're going to get it directly from the sklearn library. This is very important. Whenever you are performing linear regressions operations, all those operation related methods, functions are available in the library called it as a sklearn. Okay.
Okay.
Please guys, from this point onwards, this one don't copy anything, because just for calculation purpose I had shown you. And now onwards, this one you please try to copy this one, because this is, you should know what is this sklearn. Sklearn, it provides a lot of functions with respect to my linear, not only in general, I'll tell you, all related to regressions. Okay. Yeah, please copy this first one. What I had done, I had used n number of libraries. One is what? Matplotlib. Why it is? For plotting the graphs. NumPy, it is providing a functions called it as a mean, max, and all even arrays also. Sorry, it is, I am going for arrays. I need an array. I'm using num functions. And one more, till now, since from last 2 days, I have never shown you this one. This is a sklearn. What is this? Again, it is a library. It provides what? So many ready-made data sets also available, that I'll show you. See here, I am using the one of the data set called it as a diabetics. It is readily available, that I am using. And another one is, I want to apply the linear model regression. That is why I'll call the function called it as a linear model. Apart from these two, I need a few more statistical function. Say mean square. I wanted to calculate the mean square error and R square, because let me know how the correlation, between the two variables. So these are what? This is also I am importing, where this is from the sklearn dot matrix. Okay. Please copy this, guys. Line number 43, you please copy. Simultaneously, we'll do it.
Yeah.
Okay. Okay. See here, I am loading the data set here in this one.
Yeah.
Diabetics is one of the data set I will use. This is already available in the sklearn. See here, data sets. Where is this data sets? It is there in my sklearn library, that I will load. Okay, let me check how it looks. See here. What is the, how the data set is looks? I will just give the name. See, this is what the data set is consisting of. Okay, arrays, so many values, data with target, oh sorry, and then see here, feature name, age, all these things, parameters are also there. This is what we have in the, okay, this is the data set I have. Okay, let me check. I'll clear this one, otherwise it will make okay, this is how my database is there. Now let me implementing this data set. See here, data set data. What happens? All the rows. Okay, I'm taking all the rows and all the rows and the columns. That is what this line number is splitting. Yeah, this one is important. Here, what we are going to performing, we are taking, see, in the entire data set, we are taking what to say, some set, say 70% of the data we are going to putting for test, rest of the 30% of the data we are that is 70% of the data we are going to putting into this train, and another 30% of the data we are using for the training, for the testing purposes. Why? Because I will build a model by using the train. Whatever the outcome prediction is there, that I am comparing with my test data. Both train data with the model, if working fine with the train and test data, then my accuracy of the model is good. That is why always in we are take the data only 70%. Some in industries they may go to taking 75%, 80%. So usually train is having some few percent of data. Rest of the data will going use for the test. That is what here the 30 line is meant for. Okay, guys.
Yep.
See, split the target into training and a test. Now, see here, that is what this is with respect to x-axis, this is with respect to the y-axis. Okay, now look at here. Simply here, what I am performing, here I am performing, see, this is what I had taken some percentage of data and all. Look at here, I am performing linear model dot linear regression. Just I am calling directly this linear regression method. Where it is available? It is available in my sklearn. See here, sklearn provides this functions. See here, this is linear model dot what? Where is my linear model? Linear model is there in my sklearn. What I have imported? Data set, because I need a ready-made data set, that is diabetics, that I am using. Where it is available? In a data sets. What I am using, one more method, that is I'm importing linear model. In this linear model, I will call what? Linear regression. Guys, are you understanding here? Regression is linear model dot what? Linear regression.
Yeah.
Now I will say that is the train the model using, that is this the model. Somebody, some voice is disturbing me here. Please mute it. Okay. Now fitting my model with what I am calling this regression dot fit with x train and a y train value. Look at here. This is the copy x is equal to true. All this n number of jumps is normalized is equal to far. This is what happens. Then what I'll do, see here, this is the model I have created. Just I'll make a prediction using the tested. See, now I have used with what? Train. Rest of the 30% of the data, that is 70% I have used in regression fit for the training the model, or I'm building the model. That model, what I will do, I will test with, see, make a prediction using the test data. What I'll do? Prediction with this one. Okay, now let me check, that is the coefficient, mean square error, variance square, all these things I will printing. See, regression dot coefficient, mean square error. In this mean square error, what I'm going to say, y test, what I have built the model, and see what is actually and what I have predicted. Comparison, that variance score also, see here, r square, directly I'm using this function r square, that is the actual value and a predicted value. These are the variance that it will going to be get printed. See, coefficient, how much it is my beta 1? 9.4. Mean square error is what? 3000 something, and variance is what? 0.41. Okay, let me plot how it looks. See here. This is what the value. I mean, some of them, see, are so many of them are very far away from my this one. Can we call this as outliers, guys? Have you heard about outliers?
Yeah.
Yeah, outliers, because see this one blue one of the data, it is very far away from my this best fit line, that is the red line, correct? Few of them are on the line, few of them are above the line. Okay, some of them very far away. So what happens, we'll go to delete these points so that accuracy of my model will going to be get increases. See here, everything. See, mean square error. Directly I am using this mean square error function r square to know my accuracy of my model. Now I'll use this scatter plot with the data X test, Y test, that is your points, and see, X test is actual value, Y test is what? Color is what? Red color is, and line width is this one, the difference. So I'm using this plot to draw this. Okay, guys, are you understanding? Hello?
Yeah, yeah.
Okay, this is what, see, I'm telling you again, I'm loading my what data set, and then I'm taking all the rows and the columns. Okay, then after taking all the values into the X, what happens? I'll take only the 70% and 30%. 70% is there in train, 30% is there with respect to test. Again, with respect to Y also, I'll take 70% and 30% in test. Now I'll directly using the linear regression model, that is a linear model dot regression. After the regression model, that I'll go to for this regression fit, I'm applying what my train and extrain, while passing these two values with respect to independent value and a dependent value. So this is what my regression fit line will be. Then whatever the model I have created in line number 50, for that I am applying for my test. Okay, test, whatever the test, that is what the predicted. I do comparison, that is the mean square error. What is the difference between the actual and a predicted? That is given by mean square error. Okay, adjusted R square is for the test. And this is what directly I am performing the operations. Okay, guys, please. I'm audible. Are you listening? Any doubts you have, please let me know. Guys, this is with respect to multilinear regression. More than one independent variables you have, when you have a set of independent variables, then we'll go with the multilinear regression, right? Same sets of we are using, that is MATLAB, then NumPy. Here we have a data set, data sets, linear model, matrix. These are the some of the methods that I'm going to using from my sklearn library. Okay, here I'm using the different data set, that is the Houston. Let me check how it looks. This is what my data set. Okay, something it has been scattered here. Okay, this is the data set I have. Now what happens? See here, this is the data set I have. Now here, see here, define the what is the feature matrix X and X, feature matrix X and response variable Y. What is this X? X is post under data and target. Y is my target variable. Okay, directly I am taking this data with as a date and target. Now, just now I told you, split the data set into the training and what testing data. See here, I am using from sklearn model selection import. Here again we have a ready-made function called it as a train test split function. See here, what are the values? See, X train, X test, Y train, and a Y test. Now I am using this function train test split. Just I am passing the value of X, that is data. Y is what? Target. Test size, how much you want? 0.7. Remain, that is the status is the randomly, that is a random synthesis. Here we are not going to taking the value that is 70% or 80% linearly. We are going to taking a random data we are going to taking. That is why we made random status is equal to 1. Okay, now this is what splitting. See here, now I'm using this function directly, that is linear model, linear regression. Then I'm putting the data train and train data. Then I'm checking the coefficient. Then I'm performing variance, that is variance, and I'm performing the prediction with respect to that is I'm performing on the test data. I'm comparing the test data with the predicted data with the actual. Okay, that everything that I will put it into the residual errors, everything I'll put it into the graph. That is what here the model will performs. See, this is what the coefficient with respect to my x-axis. Okay, variance is 0.70%, 70% variation is there in the data. See here, this is what the data that is here, the graph with respect to my boosted data set, right?
Yeah.
Okay.
Yeah.
This is about what to say, multilinear regression. Then what to say, this is the second example. It shows directly how to use from my model, that is a linear regression function directly. That is here in the beginning how it is actually, it is we are calculating. For that I had defined a one main function and a plot regression line, then coefficient functions, so on, right? This is what, guys, it will take a lot of time to type and all Python files. Is it okay?
Okay. Okay. Yeah.
No issues, no? Or you want to type, or you want to do it, you want to practice it, this one?
I think just go ahead, ma'am.
Okay, I will